So welcome to the monthly Atlanta Robotics monthly meetup. This is September's meetup, and we're back with Greenzie. Greenzie actually kicked us off for our first one when we rebooted the group. So I'm happy to make a quick introduction. Before I get to introducing our speaker tonight, I think there's a few announcements. Milton, do you want to make an announcement about Maker Faire?
Absolutely.
You have the floor.
So my name is Milton Walker. I'm the Executive Director of Southeast Makers Alliance, who organizes Maker Faire Atlanta. Is anybody familiar with Maker Faire? I know we got a few folks. So Maker Faire is at the end of this month, 28th and 29th, and it's at GSU Stadium, which is formerly Turner Field. If you haven't been to a Maker Faire is like the biggest show and tell on earth, I guess you could say, all of the Maker Fairs combined. But Maker Faire is about crafting, creativity, robotics, all kinds of things that people make. And so if you're looking for some inspiration or to see some cool stuff, come out to Maker Faire Atlanta on September 28th and 29th.
And so you've got flyers?
I do have some flyers here if you want to grab some.
Please tell people about it. Yeah, I love it. All the first teams are there usually, a lot of first robotics teams, a lot of car stuff, like, was it like kit cars and stuff like that?
So so this year we'll actually have power racing series. If you're familiar with the little kid cars that have they go 2 miles per hour. Well, power racing soups them up and they go 20, 30, 40 miles per hour. So, it's interesting stuff.
Very cool. Any other announcements or other things that anyone wants to announce? Cool. Well, without further ado, let me introduce our speaker. Our speaker is Evan Davies. Evan is a robotics systems engineer at Greenzie, and we are happy to have him. He's just going to give an update on what Greenzie does in the robotics field, and he'll be open for questions. Evan's background, he was a double major at Georgia Tech in mechanical and electrical, and then he went and got his master's in mechanical and robotics, technically. So we're happy to have him. He's a robotics expert, so try and stump him with questions on adaptive control and all these other words that I don't know anything about. All right, without further ado, Evan, take it away.
Well, please don't trust him. Yeah, he just likes to say keywords.
Exactly.
So, as CBQ said, my name is Evan Davis, and I'm one of the robotics system engineers at Greenzie. Greenzie was a startup based in this building, ATV, and our goal is to free humans from repetitive outdoor labor. And so we're doing this by developing retrofit kits for commercial-grade robotic lawnmowers. And so some of you might ask, well, don't RoboMowers already exist, or doesn't that company that makes the Roomba, like iRobot or something, aren't they making a RoboMower? And the answer is yes. RoboMowers do exist, but in our minds, they're actually fairly limited and rather dumb. So RoboMower, the way that they work is they require a metal line to be installed underneath the boundary of your property that you're trying to cut. And so then they use that as a guide to know where they're allowed to go and where they're not allowed to go. And then they just aimlessly drive around hoping that they've actually fully cut everything. By the time they've actually cut your lawn, it's time for them to cut it again. And so this works sort of. It works actually fairly decently, to be fair, for like small to medium-sized residential properties. But when you start looking at like large fields and like town parks and everything, it's pretty impractical. And so the market that we're actually trying to hit are these large green spaces that commercial landscaping crews actually deal with. And so what we're doing is we're working on automating large commercial lawn mowers, such as the one on the right, and that landscaping crews use to cut large spaces such as sports fields and town parks. In these environments, there's usually 1 or 2 operators who are literally just going back and forth, cutting the grass in a stripe-like pattern. Then you have a third operator who is usually leafing and edging the sides. And then you have the 4th operator who is trimming as well as like blowing and cleaning up any mess. And so our goal is to reduce the operators by automating the striping component of cutting landscaping business by actually allowing the lawnmower to do it autonomously while the operators can actually spend their time working on the more detailed work such as trimming, edging, leaf blowing, etc. And so this would actually allow landscaping companies to reduce crews of 3 to 4 down to 2-person crews, saving them a lot of saving them people on the crews, allowing them to actually expand and put more crews out to cover more properties at the same time. And this is beneficial because there's actually a very large labor shortage in the landscaping industry, primarily because not a lot of people are willing to work outside in the sun for 8 hours a day, especially in Atlanta where it's very hot. So this actually is, we don't actually, our intention is not to actually take away jobs, it's actually to provide more opportunities for them to provide, do more, get more business because they can actually do more jobs at the same time. So one of the ways that the way that we actually use do our software is we are using a framework known as Robot Operating System, or ROS. And this framework allows us to develop our platforms. ROS is pretty neat because it provides a very modular approach to developing software for robots, and it allows us to incorporate a lot of different sensors into our system without a lot of hassle. Also, a pretty neat thing about ROS is it's pretty much all open source, which means that there's a lot of support for different libraries and packages that are associated with ROS that are maintained by some really brilliant programs out there, and so you don't have to develop everything from scratch. This is nice, so we don't have to reinvent the wheel every time we're developing things, and instead we can actually take existing solutions and then only actually have to spend our time tweaking and improving them to do our specific goals, which saves us a lot of time and work. So this is actually the framework of our software diagram. And so the neat thing about ROS is that each of these different boxes, at least the green ones, they represent different nodes inside ROS. And so what these, so with these nodes, as long as you follow the framework within ROS and the nodes themselves, they actually act very plug and playable. You can swap out these nodes for like a custom one that you've developed that does a similar feature. And as long as you're using the same techniques, such as long as you have like the same inputs and the same expected outputs, or similar outputs, ROS itself, like the ROS system, will work and allow you to swap these nodes in and out pretty easily. Good question?
Just a quick question. I saw some orphan nodes, but I was curious about what you guys are using, like what are you using the 4G modem for?
Sure.
What kind of data do you bring back that's not necessarily real time?
So we use the 4G modem primarily for the interface between the human operator and the lawnmower. So the operator is going to be disconnected from the lawnmower. So the 4G modem, basically the lawnmower will map out its location. The human operator will map out the location that lawnmower is supposed to cut, and then they'll receive through an interface, either text message or web app, like a notification of, hey, this is the boundary that you did. These are the strike path that we're supposed to do. Are you ready to go?
So that's
and
still like on a hand,
and it'll be a completely handheld, separate interface that they have instead of directly on the lawnmower. We also are looking at using the 4G for correctional data on the GPS. Right now we have an RTK system for a GPS, which gives us a base station. Basically, by using a base station with the GPS on your lawnmower or on any robotic device, you can actually get centimeter level accuracy. However, it does mean you have to have a separate base station, GPS base station, located on the property. With correctional data, you can get similar performance over the air through 4G or 3G.
Have you guys started looking at 5G and some millimeter location?
We started to, it's a little difficult on.
I don't know if I asked you this, but I was
Yeah, Sprint's been a big partner for us and is pushing us on that. They actually gave us the 4G LTE, made us switch over from Google Fi because they're like, stop using that, you can use this. But yeah, we just went to the big launch of the Smart City, and they're rolling out 5G, and it has a lot of that positional data. There's obviously nothing yet, there's not a lot of infrastructure, but there you could do micro positioning where you could say a car comes by or something else comes by and is like, hey, here's how far you are away from me, and weather and all kinds of neat stuff. The other thing I'll say, so we're not doing anything, but we are ready. And the other thing we do on 4G is every time it boots up, it does apt-get update and then brings down all our packages. So that's also nice.
And so going off that, the nice thing about that is that means our lawnmowers are always updated with it. So if the developers, we send out a fix, the next night, that night, all the
Actually, when
lawnmowers,
it boots up.
or when it boots up, any of the lawnmowers on our system will get updated with all those fixes instead of us having to manually go and re-update them ourselves. So some of the sensors that we're currently using for our localization navigation are we're using a 9 degree of freedom IMU, which gives us our orientation and then also tells us how fast we're accelerating. And then we also have encoders on our wheels, which provide us with our velocity and how fast we're actually moving. And then we have this GPS, which tells us a position with respect to the world, which is very important for our mapping. And so like I sort of already mentioned, the cool thing about the GPSs right now is there's been a lot of improvements in the technology and cost and price reduction in the last few years for them. And so we're using what's known as real-time kinematics on our GPS, which uses base station plus the GPS on the lawnmower, and that gives us centimeter level accuracy on the GPS, which is what allows us to actually accurately strike and also do boundaries. Typical GPS is about 1 meter, so instead of being like this far, they're usually off by about this much or within about that much tolerance. So it's actually one of the key components of allowing us to get our stuff working pretty well. And then so we actually take all of this data and then fuse it in what's known as an extended Kalman filter. And so that fuses all of the sensor data in together, and based on statistical analysis and on how much you trust your data sources, it provides an output of fairly accurate output of what your robot's doing at any given moment. And this is how we're able to actually fairly accurately strike everything. Yep.
So do you use the camera for visual odometry, or not really, right? Because you don't have any features on the grass, right? Or
So, actually, talking about that. So, we currently do not use the camera for visual odometry. I'm going to put Thomas on the spot. So we actually just hired a new software engineer. Hi, Thomas. Say hi. And so actually one of his first projects is taking the RealSense. So we have a RealSense camera on, Intel RealSense camera on our lawnmower right now. And one of his first projects actually is going to be partly exploring using visual odometry as another source of sensor data for odometry and counter filters. So currently, no, it's in the works, at least to be explored, depending on how well it turns out. So talking
I think
about,
Thomas just found that out.
yeah,
right.
by the way,
Yeah,
by the
I'm
way,
really
Thomas,
excited about it.
Congrats, that's your first project.
Yeah,
So yeah, talking about the RealSense, so we on the lawnmower we do have a RealSense camera, excuse me, and so that actually uses IR camera data as well as depth sensor to be able to create a fairly reliable amount of camera information for a lawnmower. We don't currently use it really for much. Some of the steps that we're working on developing with that are visual odometry as well as object detection. One of the biggest concerns our customers have told us about, or potential clients have told us, is that the lawnmower has to be able to detect if someone runs in front of it, needs to be able to stop. One of the other things we've noticed is, if it'll let me play it again, is so in one of our clients' places, you can see there's this black line right there. That's actually a pretty big ditch that if the lawnmower ran into it, could very easily get stuck, or if the blades are on, it could very easily damage the blades. And so that's one of the other potential difficulties, is detecting ditches as well as other just objects and knowing to either avoid it or stop, let the human operator move it out of the way of those objects.
Yeah, hit play. I think we go into it, don't we?
We get pretty close to it. I don't think we actually go into it.
I think we do. Like we put the front wheels down, so it goes.
Yeah. And so the goal would be to actually detect that beforehand, so we don't actually go into it. We drove into it intentionally manually, just to sort of give the effect of it. So now that I've spent all this time talking, now that I actually show you a video of what we're actually doing, it's way cooler than me talking. Hopefully. So this is one of our lawnmowers that we're using, which is an all-electric lawnmower.
This one is so great. We're right next to the parking deck.
Yes.
I love this one.
The very nice thing about it is it's extremely quiet. Unlike a gas lawnmower, it doesn't have a gas engine, so it doesn't make all that noise. You can barely tell it's actually moving. You can actually talk over it, unlike all the other gas ones. And so like we typically drew the boundary ourselves, and then the lawnmower is actually cutting and striping. There's an overlay of what it did physically, like seen on the lawn. There's also then that was artists that was showing the stripes on the software. And so we also have some safety features, wireless pauses and e-stops to ensure that we can stop it, and then we can make it drive itself up on the ramps. So that's where we're currently at. And then of course it's always fun to have it's always good to have a little bit of fun. And so this is us playing tag.
Safety first.
Helmets, nothing, man.
You gotta have fun once in a
Until you
while.
catch it.
That's always just a fun one. So I hope you've enjoyed hearing a little bit about what we've been doing developing at Greenzie. Do any of you have questions about what we've been doing? Yeah.
This is a very general question. I just wanted you to say, what do you think so far in the development cycle of this has been the biggest hurdle for you to overcome?
So definitely localization.
Can you repeat the question?
So the question is, what is the biggest hurdle that we've had in the development of the cycle? And so the answer definitely would be localization and navigation. We've done a very good job of, on the low level, interfacing with the hardware, hijacking the hardware's existing design, and then being able to interface with that and tell it what to do. And then we've done a good job on the high level, sort of path planning and being able to develop all these stripes, and then also interfacing over web and wirelessly. Where we're currently having to spend a lot of our energy is in that mid-level, taking our sensor data, fusing together, and telling us reliably where we are with respect to the world, as well as where we are, and then also where the robot thinks it is. And it's that fusing of those two data sets that gets a little bit difficult, because we actually end up having to have two different Kalman filters, one that uses the GPS and one that doesn't. Because the GPS, if you run into an place where you lose GPS data, it's a discontinuous signal, which can cause a lot of issues with your with some of the calculations in the mid-level, and so you have to sort of update your a local map framework, one that doesn't have the GPS, with the GPS data, and it's getting that timed and set up and synced properly has been very difficult for us.
Thank you.
Yeah.
I may have missed this, my apologies for being late. Work has a strange sense of humor, they want me to earn the money they pay. I notice it's quite a bit bigger than most of the other robotic lawnmowers. Is that mostly due to battery and it goes a larger space, or?
Yeah, so the question is, why is this one so much bigger than all the other robotic lawnmowers? And so the answer is, those robotic lawnmowers, the robomowers, are typically used for small, residential houses with fairly small lawns, and they just continuously mow around, and eventually they get the whole lawn cut. What we're targeting is the market that are dealing with the larger fields, so sports complex or town parks, where you can't have them be cutting for 10 to 12 hours. It needs to be cut in an hour or two. And so we're targeting the larger landscaping crews where you have 2 or 3 different people working on one location at a time to get it done in an hour or two. Yeah.
Any plans to put solar panels on it so it could?
I want to.
Yeah.
I think there's the top of we have 2 different lawnmowers. There's a gas one and then there's an electric one. And the top of the electric one, there's a big flat plate, which is to access the battery. It's a huge battery. It weighs probably 500 or 600 pounds. But that huge plate, I think, would be a perfect location for solar panels. We'll see if we ever get there. I think it could be a nice accessory.
Well, I'll also say there's another mowing company, we don't produce the mowers, which is great. They're great technology, we love using them, we love both the companies that we buy them from, Exmark and Greenworks Commercial. There's another one out there, Mean Green Mowers, maybe they're listening. We've spoken to them. They have a version that is electric that also has some solar on the top. There's an option you can add. It can just be done for kind of charging the starter, because it's not that much. So you need a big solar array to really generate a lot. And it's constantly moving around, and it's also kind of expensive, because that's the first thing that landscapers do is hit something. So that one's kind of interesting, and they kind of show it on their website. But if they were, I would love to buy one, and I would buy it for cheap if you'd let me. We'll automate it, but there are some out there.
Okay.
So we'll see. Yep.
Have you guys thought about logistics of maybe when you actually are deploying these all over the country and how you're gonna maintain them or have them do self-diagnostics on what's wrong with them?
We are starting to get into having to worry about that. So for this upcoming mowing season, so around next year, starting like around March, April, our goal is to have 5 units available, and they will be located in Atlanta because of all of those logistics. And then the goal would be the mowing season after that have about 100, and most of them would be spaced around Atlanta. But then, depending on the interest, primarily the southeast region. At that point, hopefully, we'll be a much larger company and have dedicated people to do logistics.
Yeah, I mean, a lot of the stuff though that we've done so far, if you think about, we're using, the app system, that scales great.
Yeah.
Right now we have like a secure open VPN, so we've thought about a lot of this. We've had some really good consulting and software developers thinking about this for scaling out. So we have a provisioning system, it's based on Linux, it's got a quick boot, small kernel. We're using a lot of off the shelf, so components, there's not a lot of custom. There's a little bit on the hardware side, but we think we can kind of machine that and 3D print some of that, even the metal stuff. So, I mean, I think it can be scaled. I think the hard part, as you said, is like, I don't want to be SSHing into, 500 machines and doing an update or whatever, fix. And so we have some tools to do that. And we've been pretty impressed with just apt-get update, Debian packaging. It's solid, it has a rollback, if it fails, and it'll always boot up. So, but yeah, there's a lot to be thought about. We're looking for help.
So for localization, right? I mean, when you lose the GPS signal, I wonder if you can use some of the cellular information, the 4G information, or maybe even some other constellation like GLONASS or something.
Yeah, that's one thing we're looking into exploring. We haven't got to that. We haven't been able to test that out yet. But we are looking, since we have the 4G, we've started. Since we already have the 4G platform installed on our system, it's like, well, we may as well start looking to see what other uses we can use it for. So yeah, very good on that.
How long do you lose GPS for typically?
It's usually, I mean, it depends on the properties. The bigger concern is if you lose the quality of your GPS and it starts jumping around a lot, then the EKF will also start jumping around a lot, and that will really mess up all your control systems because it will think that it's jumping the meter back and forth very frequently. I think you had a question.
Yeah, there's a group up off of, up in Alpharetta off West Side Parkway, XYZ Solutions. They're a subsidiary of Trimble.
Yeah.
They run Caterpillar equipment out to build airport or runways autonomously, right? And I didn't know if you had advisors or consultancies and wanted to throw anybody on the pile, but I worked with that group back in 2008. Wonderful group of people, really cool kind of virtual modeling of their equipment running, complete with sound effects and everything. But there might be some people kind of up in that area that
What's that? Yeah.
help crack open some of the locationing, positioning type information. So anyway, Tribble's got some bit of a footprint there, and they're not competitive with you, right? Which is always a nice combination. Advisors that aren't going to steal. Oh, maybe I don't know. Steal your idea. So.
I don't worry about stealing. I mean, our